I actually think that AI is not developing fast enough. Uh, I honestly, es que, again, maybe perhaps my point of view comes from the perspective that I am a scientist that utilizes this tool every day with the expectation to help me solve problems for biomedicine.
I'm really excited to ask you about your research because it's absolutely groundbreaking and potentially revolutionary. It's covering so many interesting topics that people are very kind of keen to find out a bit more about. So I was just wondering, to kick off, if we could start by learning a little bit more about you and about how you came to do the research you do today. So I know you have a PhD in astronomy, and now you're researching in a slightly different area. So if you could just tell me a little bit about that would be great.
Yes, of course. Well, I have a ground in physics. I did my first degree in physics and also my master's degree. And as you mentioned, I had a PhD in astronomy. I focus more on cosmological models of the universe, dark energy theories. And I really enjoyed my time in that field. I really love physics. I think it's a very good degree for many scientists, and of course not for everybody, but for many scientists to start their path in research. And then after that, I actually worked in industry for 2 years. So I was working as a data analyst for computer game companies in Scotland. And although I gained a lot from that experience, I realized very early on that I missed science very much. So I started trying to put together applications in order to go back to research. But at the time, I was very keen on either doing research on climate science or on biomedicine. And I came across this program from the University of Edinburgh called the crossdisciplinary postdoctoral fellowships. And what this program was about was, bringing quantitative scientists. They could be, for example, mathematicians, physicists, computer scientists, and related areas, but that wanted to apply those skills into biology in order to solve biomedical problems. So, so I applied. Thankfully, I got an interview. I was accepted, and here I am now.
Yeah, and that's super interesting. So I think one thing to kind of flag up, or that I'd like to dig in on initially, is going from physics to this sort of biochemical, medical element of research. That must have been really difficult, that cross-disciplinary element. So I was wondering if you have any kind of advice. You must be really good at learning and really good at assimilating large amounts of complex information and that sort of thing. I was wondering if you had any kind of advice for people on how they can optimize the learning process, optimize their sort of cognitive function, if you like, and
Okay.
apply their learning to different walks of life, like you have.
Okay. Well, I actually think that I am an avid follower of sports. I promise I'm going somewhere with this.
Oh, right. Don't worry. No. You go.
Yeah. So I really like to follow or to do activities where you need to push your body in certain ways. And I actually think that I have learned a lot from observing others in sport activities or performing them myself, and how to use some of those skills to my work, to my academic
Yeah.
work, and what's referring to your question on learning. Um, so I think what has really worked for me is to be consistent. So it's sometimes during an academic career at any level, I think, you know, it is common that administrative tasks start piling up, or
Yes.
you know, or
Yeah,
commit.
absolutely.
You're right. Yeah. So, or commitments that are important, of course, but not research per se. Research that needs, to really focus, to really think hard about a problem. And I think what has worked for me is to try my hardest to allocate some time every single day to research, and nothing else, and to do honestly everything I can to make that time, to protect. But I don't think it is realistic to, for example, try and say, oh, I'm going to spend 7 hours of my day, doing research, because okay, maybe some people can do it, but I honestly, I can't. I think the other things I have to do will start to climb. But rather than a large number of hours, is to do it every single day.
Yeah.
Come what may. And I think that's what I take, in relation to sports. I feel that a lot of athletes, from what I have read, what I have seen, it's very important that they don't have to be brilliant every single day, they don't have to have the best practice every single day, but they have to show up and try
Yes.
every single day. Um, and I think that in that aspect, learning new concept, learning, understanding concepts more deeply, answering problems, is something that really has helped me. So perhaps it could help others. Another thing I will say is that, and again, in relation to sports. So I practice dance. I really like dancing. And one thing I have found with dancing is that sometimes, I need to push myself really hard, to really try very hard to um, to perfect a step, to improve a step, for example, or a certain aspect of my dancing. But then also at some times, at some points, I need to really relax and just, let my body do what it does, without me putting so much pressure. And again, I think in research or when learning, I have found that this duality of sometimes, trying very hard, focusing very hard on something, but then also sometimes like almost letting your mind, do it, but without you putting so much pressure, just kind of, I don't know, coming up with ideas. If it works, if it works. If it doesn't, it doesn't. Almost like, I'm not saying not caring, but really relaxing into it. And sometimes you need one, sometimes you need the other. I feel like that has helped me. But yeah,
No, absolutely. That's fascinating. So, as you said, it's striking that balance between the sort of consistency and the being regimented and showing up and make sure you do some sort of research based work every day, but also not kind of not forcing it, letting it come and not sort of over stressing about things. And maybe while you do something else, it's processing in the background, to use a kind of computer
yeah,
analogy. Sometimes ideas come to you
absolutely.
at funny times, but if you hadn't done that consistent work earlier, perhaps your brain wouldn't have been ticking over in that way, and you may not have had that breakthrough. That's super interesting. So, turning to your research now, could you tell me a bit about what you're researching at the moment and how you're
At the moment.
researching it? Yes, please.
Yeah. Well, my research is about utilizing, computational techniques, very broadly speaking. That could be, artificial intelligence models, for instance. But really, really, a lot of what I do is also data analysis. So let's call it computational techniques, and try to apply those computational techniques in order to discover drugs. I suppose in a nutshell, that is what I do. I, one of the advantages, I suppose, of what I do, is that I suppose ideally, or in an ideal world, I could apply these techniques to a very large number of diseases. But in reality, I personally, that's not what I like to do. I like to focus on a few. So, for example, at the moment, I work on brain cancer. esophageal cancer, and aging related diseases. And of course, the techniques I use, could be applied by others in other areas, but I do worry that if I try to apply to too many areas, that I will spread myself too thin. Um, so I rather understand as much as I can of the biology of these diseases, than trying to go for a lot without
I
much
can
depth.
imagine it's enormously complex research, right? So we're in enormously complex areas. So you really do need that fine grained analysis. And that makes a lot of sense about not spreading yourself too thinly. So my first question on that is, we've talked about AI and machine learning and computational models you just mentioned. Could you tell me a little bit about, so people will use the term AI very generally, and then within that or related to that, and I'm showing my ignorance here, but there will be things like machine learning and deep learning and computational models. Could you just explain a little bit about the differences and about how you would use those terms?
Yes, yes. No, I actually think it's a very valid point, and it's something that I have definitely thought about before in terms of, when I'm writing a grant or a paper or giving a talk. Um, I don't I sometimes I don't like to repeat. For example, if I'm writing, I don't like to write in the same paragraph machine learning three times.
Yeah.
So sometimes actually, depending on the situation, I will sometimes write artificial intelligence, and then if the situation is appropriate, machine learning and so on. So no, I think it's a very valid question. I think, as I understand, that artificial intelligence is a more broader term, that we could say applies to computational techniques that are trying somehow to um, learn, and make predictions, very, very generally.
Yeah.
But then within that universe, let's say, there is a part of that universe that is called machine learning. And what machine learning tries to do is to predict, to learn patterns, but this type of models have to do it from data. So this is I suppose, the very important point, is the inclusion of data. Machine learning without data cannot do anything. It is indispensable for it to use data.
So
Whereas, uh
yeah. No, no. So what I was going to say
yeah.
is, I mean, the more presumably, and this is my kind of layman's understanding, but the more data it has, the more effective it can be.
Yes,
And I,
exactly. Yes,
yeah,
yeah.
and I was
And actually,
gonna.
when you
Sorry, you go.
Sorry, no, no. Yeah, I mean, the point you make also about the amount of data is very crucial here, because another term that it's very common to hear is the term deep learning. So we hear
Yes,
machine learning and deep learning, right?
yes.
So if we make the circle even smaller, within machine learning, there is another smaller circle, which is the circle of deep learning. And what that means really is machine learning models that utilize neural networks, or neural networks of one kind or of another kind. Um, and generally, what happens is that in order for neural networks to perform well, I'm being very general here,
No, that's
um,
great.
you need to provide them. Sorry,
That's
you
great.
need to provide them with much more data
Yeah,
than other types of machine learning models. We could say that neural networks are data hungry, to put it somehow.
I think that's a good way of putting it. And so the next thing I wanted to ask you about, and thank you for that explanation, is drug discovery and this process of drug discovery. And the fact that if you do it, I don't know whether this is correct, but I want to say the old fashioned way, i.e., in a lab, physically doing it. That's a very time consuming and costly process, right? So I'd like to ask you a bit more about the drug discovery process and the potential applications of AI, of machine learning or deep learning in the drug discovery process, and the advantages and the sort of developments that it can bring.
So generally, the way that the drug discovery, the artificial intelligence, machine learning models can help the drug discovery process is to make it faster, because drug discovery, basically independently of the disease to which it is applied, it's a very long process. It can take 10 to 20 years to approve a single drug that can actually, be given to patients, and it's also very costly. It can cost, again, between $1 to $2 billion, to for that to
Yeah.
happen. So obviously, for many diseases, we will wish for a much shorter and affordable process. Um, and this is how, machine learning, deep learning have the potential to help, because what can happen is that this type of models, as we were mentioning before, they have the ability to learn from data. So if we feed these models a relatively small amount of data, they can potentially learn what makes a good drug for a certain disease and what doesn't, what it doesn't. And then they can be used to predict on new drugs that have never been tested in the lab, for example, or have not been tested under certain cellular conditions for certain diseases. And really, this machine learning process is incredibly fast. I own a MacBook, which is a good computer, but there is nothing special really about it. You can go and buy it in the shop, and many other computers will absolutely do the job. And the process can really take a few minutes. Really, it is that fast. Of course, it is not perfect. The machine learning models make mistakes. We have ways to measure, or get a sense of what type of mistakes they are making, and we, of course, we still need to follow the experimental protocols as rigorously as always. But instead of testing 10,000 drugs, these models can potentially help us to test 20, you
Yeah.
know, of which that have a higher probability of having the behavior we want. And then, well, of course, this is a massive save. This is a massive save in terms of resources, time and money spent. So
Yeah, and as you said, it's potentially revolutionary in that instead of having to physically do it all in a lab, the sort of lab bench work, you can actually do it, as you said, simulating via a computer model. So, could you tell me a little bit more about the research and the breakthrough that you've just recently had regarding senolytics? And if you could also just very briefly explain, what senolytics are for anyone who might have questions on that.
yes, of course. Well, senolytics are a type of drug which, it's fairly novel. It's not a drug that has been known for ages and ages. I suppose um, probably the last decades, being very general, perhaps a little less than that, is where the research on senolytics has made progress. But the idea of these drugs is that they are able to kill a certain type of cell that we all have in our bodies, which are called senescent cells. I'll explain a little bit more about what those are in a moment. But they also have the ability to keep normal cells alive. So that's why they are called selective drugs. They only attack to put it somehow, the bad cells. Um, so these senescent cells are cells that, for example, just to give a very simple example, if you have a mole in your body, it could well be that the cells that make that mole are senescent. So these are cells that are alive, but that they do not reproduce anymore. They do not duplicate and reproduce anymore. They are in this sort of zombie state. They are metabolically active. They consume nutrients, but they don't divide. And the problem with these cells is that in many occasions they can have damage in their DNA, and that can cause a variety of problems. So something that has been observed, for example, in certain models, is that for some diseases which are related to old age, for example, arthritis, diabetes, COVID, even certain types of cancer, you can observe that there are senescent cells present. um, and the idea is that if you give a senolytic to to people with these conditions, the senescent cells are then cleared and the condition improves. That is the hypothesis that generally the work with senolytics is trying to put forward. Again, I'm being general. There are specific things, and I have to say also, and this is something that rightly has been pointed out by senescence experts, and it is that sometimes senescent cells are good for us. There are certain conditions in which senescent cells have an important function to make. For example, when in embryogenesis at some point. Um, so it is not an indiscriminate elimination of senescent cells. It has to be something quite well thought. But yeah,
That makes a lot of sense. So it's not a case of just eliminating all these so-called zombie cells and you'll be much healthier. It's much more nuanced than that. And in as you said, in certain respects, they can actually be good for you and be necessary. Okay, so
absolutely.
turning more towards the sort of AI side of things and the machine learning sort of things, presumably this model of drug development could be applied, very broadly. You've mentioned a few things already, but how do you sort of think about the potential of AI to impact medicine and specifically medical research and how that's done?
Well, I suppose as I said again, in order for this impact to happen, we need to have data available in order to train these models. So, for example, with my research, my recent paper, what we did was we found three senolytics, so three of these drugs that eliminate senescent cells, utilizing machine learning models. But the reason we were able to do this is because we were able to access data from other senolytic and non-senolytic drugs. So, for example, say that if a person was interested in utilizing machine learning to, I don't know, which disease could we mention? Breast cancer, just to give an example. Well, if in order for machine learning to be useful, they will need to put together a data set of drugs that work for breast cancer and drugs that do not work. Um, yeah,
So it could really, if it's given enough relevant information, it could really, and I don't want to put words in your mouth here, but expedite part of the process and speed up, the development from when it's sort of demonstrated as a concept to eventually much further down the line after clinical trials, etc., to when it could actually end up treating people. Is that correct?
yes, absolutely. So the application is at least the application that I have done, or that people who have done similar things to my work have done, is in the early phase, in the early, what we call early drug discovery. So instead of testing many drugs in the lab, you reduce that number to a smaller number of drugs to be tested. Um, yeah, the later stages of the process are not utilizing machine learning or deep learning, at least not the ones that I have used or the ones I am familiar with. It may be that there are other labs or companies who utilize machine learning for further stages, perhaps, but I will be speculating also. I simply don't know.
So I'm going to ask you to speculate again here, but we've talked a lot
Mm.
about the about AI and machine learning and the potential benefits of it. But a lot has recently been said, particularly in the media, and this has really reached the mainstream about the concerns over AI. And people have called for example, for a moratorium halting AI research. And I was just wondering, as someone who uses AI day to day, who is well placed and has a good understanding of what it can and what it can't do you have concerns over AI and concerns over the development of AI, for example? I'd just love to get your, and I know it's a very general question, but I'd love to get your perspective on it.
Yeah, I mean, of course, it is impossible not to not to realize there have been, or there are often, um, articles in the media worrying about, or worrying the population about um, concerns related to AI and so on. I think that I don't know. I have several thoughts about the subject, so I'm trying to put them in order. So I generally don't. Well, I do not agree. In general, with this hysteria around AI. Uh, for me, AI is a technology. It is not perfect. AI models are not perfect. It is, yes, of course, an important tool, but like many other tools that the human beings have developed across our stage in this earth, to be very general, if somebody has a hammer, you can utilize the hammer to put that thing in the wall, but you could also utilize it to attack somebody. You know, if you have a car, you could drive a person to school or to hospital, or you could, you know, throw the car at some other people. It is a technology, and AI is in one way the same. It's a tool. I feel like, unfortunately, it may be a tool that many people do not understand, um, and perhaps that is why there is this sense of um, of extra, fear around it. But I don't think it's totally justified. Of course, I think that it should be, um, there should be ethics about AI in place. I think that it is something that we need to do work on, the same way as, for example, um, the internet should be regulated and so on. But going from this to make to it needs a specialized knowledge, but I don't think that it needs for us to be fearful, or um, I don't think it justifies all this media, that it is getting, this negative media that it is getting. I think that um, I feel like these fears have been in place for a long time. Also in other related areas. For example, one thing you hear often is, I don't know, the fear of AI taking jobs away.
Yes.
And well, I think you're right. And the thing is, like, well, I mind that this fear probably existed for every single thing, or for most technologies that we have had from the industrial revolution and before to now. you know um, but then with technological advancements, there is also humankind progress. I think I feel that we should make more of an effort to understand and to regulate rather than to scare.
Do you have any concerns about AI developing very quickly and this idea around artificial general intelligence, as opposed to the very specific applications that you are involved with using?
So you say whether what do I think about AI developing very quickly,
Yes,
like
and
in
people
general?
exactly. People will argue
Uh-huh.
that we're at this kind of tipping point now, and that further
Right.
development will suddenly go from being a slow to like exponentially, enormously going up.
Right. Okay. Well, I honestly, my opinion is completely different. I actually think that AI is not developing fast enough. Uh, I honestly, es que, again, maybe perhaps my point of view comes from the perspective that I am a scientist that utilizes this tool every day with the expectation to help me solve problems for biomedicine. Um, and because of this, I am very aware of its limitations, which are many.
Yes.
So so I don't see where is it evolving so quickly. Frankly, I mean, maybe I'll be very, of course, open to disagreements here. This is simply my opinion from my day to day experience of it. Um, and I sometimes get frustrated because I would like to. I have problems in front of me that I want to solve, and the tool it has. I hit a wall with the limitations of the tool of artificial intelligence. So I don't, in my opinion, it is not developing fast enough. Of course, there are developments. There are papers published, and there are these ideas and that, but it does take a very long time sometimes um, to convert an idea that is on paper to an application, and it's quite hard. You know, I honestly think is harder than it looks. You, how can I how can I say this more? So I have done so, in terms of my research. When I published my paper, I made information publicly available. So when you download my paper, just to give an example of an AI application, um, which really is not like the most advanced model. No, no, no. It's just like a model that works well for what it does. You know, and uh, and I have received a good number of emails asking me for more details on how to make it work. Uh, Whereas, in my opinion, I have given a very large number of details and explanations of how to make it work, which helps to show that creating something and making it work is not automatic, even when you would make things fairly open. Um, I I will be interested, I don't know, to hear of other researchers if they have had this type of concern. But yeah, I don't see where is this fast progress happening. Please let me know about it because I would like to make use of it. Honestly, it's que, but just my opinion. Of course,
No, but
everybody has their very valid opinion.
it's so interesting, and you're in a very good and well qualified position to comment. And as you said, the potential upsides, especially for the biomedical research you do into disease, the potential upsides provide a very persuasive rationale for AI to be developed more quickly. For example, curing cancer and addressing addressing diseases of aging and these sorts of things provide a very persuasive and consequential rationale to actually expedite the development of AI. So that's such an interesting perspective that we don't often perhaps hear as much as we should, especially from a researcher involved directly in using AI for good. So I'd like to just finally ask you finally wrap up by asking, is there anything that you wish I'd asked, or is there anything that I've neglected to ask that you'd actually like to talk about? What you've just said is so interesting, and I think a lot of people will get so much value out of that, just to have a different perspective. But in summary, is there anything you wish I'd asked, or is there anything that I've neglected to ask that you'd like to talk about?
I think no. I mean, you have asked me great questions. Thank you very much for your questions. I think it really um, allowed to, you know, talk about a variety of things really well. Um, I maybe more than something to ask, I could just give a few thoughts that I don't know
Yes,
that
please. Yeah,
I have.
a few thoughts on your research and anything we've spoken about today would be fantastic. Yes, please.
Okay, so yeah, so for example, in the you know, I think that although AI is a very interesting and powerful tool, um, we still have a long way to go in order to make it achieve its full potential in biomedicine. So for example, let's take the example of cancer. You know, as said before, in order for AI to be useful in the context of achieving good therapies for cancer, we need to have data available for those diseases, and the term cancer itself is extremely high encompassing. You know, I almost feel like it is misleading sometimes because every cancer is different. Every cancer is its own disease that has its own genetic markers, that it has its own very particular characteristics. So one therapy that applies to one cancer absolutely does not mean that it will apply to another. So I think AI can help us in order to make to accelerate progress with these diseases, but it certainly we have a long way to go with AI or without it. We have a lot of research to perform, a lot of resources to be put together. Especially, there are some particular diseases that for which we have a very small number of therapies. I feel that I think it's always good to act with caution. Perhaps, you know, in term, for example, we have spoken a lot about the media, and I think this caution, it will be good to apply it to put somehow good news and also to bad news. You know, I will be very wary of grand statements. You know, for example, anything that says curing cancer. You know, wait a second. No, which cancer are we talking? What do you mean? You know, really read what's going on. What are the details there? It could be that perhaps a strong progress was made in therapies of a certain type of cancer. So, for example, in terms of breast cancer, we have done great advancements. There are many options for people who unfortunately suffer this disease. There are some numbers of breast cancers for which unfortunately treatment is much harder. But there are other diseases, for example, brain cancer, for which we really do not have many treatments available that are successful. We that's on the other end of the spectrum. So I think, yeah, probably, I will say uh, that both good news and bad news, in relation to biomedical discoveries and AI, should be uh, um, yeah, taken with caution. The
It makes a
Yeah.
lot of sense, and I think that the balanced coverage, as you said, reporting, people will report the concerns, and therefore the concerns can be artificially inflated, right? Whereas they don't necessarily report perhaps the benefits and the potential applications. So I agree. This more balanced, more analytical coverage rather than the sort of headline grabbing, sensationalist type stuff. And it's talking, it's talking to people like you who are at that cutting edge of research, who are willing to give up their time and willing to provide these insights that I think should help to inform the debate and should really help to make people more aware and also come from a more informed and considered an intelligent perspective rather than, as we just said, the hysteria and the clickbait and that sort of thing. So, well, Vanessa, I really appreciate your time. Thank you so much for joining me today. Could you just tell us about how we could find or how anybody could find a bit more about your work and a bit more about you and the sorts of things that you're doing at the moment?
Yeah, so I think I should make. I think soon I'm going to probably update my university profile and so on. But if I if you would like to see an example of drug discovery and artificial intelligence, maybe you can read my paper, which is in the journal Nature Communications, and. I also I wrote a piece for the conversation a little bit after the paper was published, which is I try to make it in a language that is accessible to many people. So yeah, if that article could I certainly touch on with your questions, Johnny, on several of the points I made in the article. And yeah, I think through the University of Edinburgh web pages, you can see the work that I've been doing, and of course that of my very valuable and important collaborators. So I work with a range of experts, biologists, chemists, computer scientists from different institutes in the university and beyond. So you can also follow their work.
Thank you. That's that's really useful. And one final question that just reminded me with what you said is this idea of, and you're a very good example of the benefits of this cross-disciplinary and interdisciplinary approach of bringing together, biologists and data analysts, data scientists to kind of facilitate faster and more effective science. I'd love to hear, because I mean, you've obviously come from physics to this biochemistry research. I'd love to hear your thoughts on kind of the benefits of cross and interdisciplinary research.
Oh well, I mean I personally love cross-disciplinary research. It really, it's very, you never get bored because there is always something more to learn, something more to understand. Um, I think that it may not be for everyone. To be honest, it does you know um, require certain skills. That's fine. There are, that's why there are a variety of researchers. Some are good in certain areas, whereas some are good in others. But I really think that if you manage to work as a team, and to support one another, and to share uh, the discoveries that you are making together, it really can be a very rewarding process, and can make for very good science. It makes the projects more robust. I think, to work in this way. I personally, I love it. I really do. It's very fun. It almost feels. I don't know. How it works exactly in the UK. I know you have the GCSEs and the A levels and so on. But in my country, and I'm from Mexico, and other countries, it was a little different in the sense that, for example, I remember when I first started high school, or the equivalent of high school here. You had to take all these subjects. You couldn't specialize on anything. You had to do Spanish, English, history, geography, biology, chemistry, physics, mathematics. And I remember having really enjoyed that time because I really like to learn. I really like to, and I found many things interesting and so on. And I sometimes feel in my current job, I feel a similar sensation as to what I had as a pre-adolescent. Having all these things to learn, and your brain has to switch on to understand mathematics in the morning, but then you have the meeting with the biologist in the afternoon, and you have to be switched on, to try and absorb. Um, I think. There is of course a room. It's very important to do focused singular research, but this approach of having to know a bit more of everything, it almost reminds me of the time of Descartes and this type of natural philosophers that they were called at the time. That when you read their biographies, it's like, oh well, they did this thing in maths, they did this thing in thermodynamics, and they did this, and like, wow, it was a very complete formation, so it's good.
That's fascinating, and I think, as you said, it's really useful to have different perspectives and have it helps provide a catalyst for perhaps new ideas and novel ideas and thinking about things, coming to problems in slightly different ways. As you said, it's such a valuable tool, and this idea of knowing and keeping despite knowing a huge amount about an area, keeping a curious mind and being aware of what you don't know, but what perhaps you could find out that might actually facilitate, even the research in that niche area. So I think that's really interesting. And someone, like you saying that, I think is particularly persuasive because you're actively involved in research in that area. So I think that's really useful. That's great. Well,
Thank you.
Vanessa, thank you so much for your time today. I really appreciate it.
No, thank you for inviting me. It's a really nice experience, and I'm always very grateful for the opportunity to voice my thoughts. It's not something that happens every day, so I'm also grateful. Thank you for having this chance of making me think. Your questions make me think. I have to really think hard. Um, what my thoughts are on a certain subject, and that's always I'm always left with more food for thought. Days later after having an experience like this, I'm like, oh, but I think about this better, and I found another example or whatever. I don't know. So it's always good.